Every few weeks, a new AI model arrives, and it always claims to be the smartest one yet. But smart is a slippery word. So, how would you actually measure it? The answer is a kind of standardized test, and the scores behind every headline hide a surprising catch. Ask any lab, and their latest model is the best in the world. The trouble is, marketing isn't measurement, and you can't take a claim like that on faith. To compare two models fairly, you have to give both the exact same questions and score them the exact same way. In other words, you need a test. So, that is exactly what researchers built. A benchmark is a fixed set of questions, each with a known right answer. You hand every model the identical exam, count how many it gets right, and suddenly the comparison is fair. Apples to apples. Here is a single question from a benchmark. The model reads it, picks one answer from the choices, and we check that against the answer key, right or wrong. On its own, one question tells you almost nothing. The real power comes from asking thousands of them, back to back. So, we run the whole test, thousands of questions, and tally every result. Green for a hit, red for a miss. Add them all up, and the model's performance collapses into a single number, a percentage, say 86%. That one number is what ends up in the headline. But a single number hides a lot, because being smart isn't one skill, it's many. So we don't lean on just one test. We use a whole suite, each aimed at a different ability. Grade school math, writing code, careful reasoning, broad knowledge, and staying safe. A model can ace one of these and quietly flunk another. Now line the models up by score and you get a leaderboard. This is where best in the world is really settled, out in the open. When a new model leaps to the top of a respected benchmark, that is the moment the whole field stops and pays attention. Still, some things just can't be graded with an answer key. How helpful is a reply? How clear? How well written? For those, we show people two answers and ask which one is better, or we let a strong model act as the judge. Same idea, but scored on preference instead of a fixed key. And here is the catch that makes the whole leaderboard tricky. These models learn from enormous slices of the internet, and the test questions often live on that same internet. If the answers leak into the training data, the model can simply memorize them, scoring high without being any smarter. It is studying with the answer sheet in hand. There is a quieter version of this too. Labs know exactly which benchmarks everyone is watching. So, there's real pressure to tune a model for those specific tests. The score climbs, while the model isn't broadly any smarter. The way a student can cram for one exam and forget all of it a week later. So, how do you read a score honestly? Lean on fresh questions the model hasn't seen, private tests it can't train against, and most of all, how it handles your own real work. A benchmark is a useful signal, not the whole truth. So, to recap, a benchmark is a shared exam that turns performance into a number. We use many of them to cover different skills, and a leaderboard ranks the results. Just remember the catch. A high score can be memorized or gamed, so always read the fine print. If this made AI click a little more, subscribe. That's one concept at a time, here on Superintelligence.